I hope you would have understood our previous session about the continuity equation. Let us start off with the types of flow in this session. There are basically two types of flows, incompressible flow and compressible flow. Incompressible flows have Mach number which is less than 0.3 and compressible flows have Mach numbers which is greater than 3. Before we proceed, it is necessary to point out that all matters in real life is incompressible to some greater or lesser extent. Always remember air is a fluid in aerodynamics. Compressible flow. That is, if we take an element of a matter and squeeze it hard enough with some pressure, the volume of the element of the matter will decrease. However, its mass will still remain the same. In compressible flow, in which the density of the fluid element can change from point to point, we can see that the flow is compressible when ρ1 is not equals to ρ2. The variable of density in aerodynamic flows in a particularly important at high speed such as all supersonic airplane and rocket engines. When it comes to incompressible flow is a myth. It can never actually occur in nature. However, for those flows in which the actual variation of ρ is negligibly small, it is convenient to make the assumption that ρ is constant, that is, density is constant. Therefore, in incompressible flow, the density of fluid is always constant. At low speed airflow, where V is less than 100 meters per second, is assumed as incompressible flow. Let us see the difference between the compressible and incompressible flows. Consider an airfoil and an airflow around it. And air has some velocity, and when it approaches the wing, its properties can change. So when the air comes and hits the airfoil, this part of the airfoil will slow down the air. This is because the airfoil is made up of metal and the airflow cannot go through it. But when the air comes around the airfoil, it has to catch up with the flow on the downstream. Hence, so here in this part, the air will speed up. So when the air flows around the airfoil, it will slow down or speed up at high speeds, then its property will change. So mainly the density will change. So now let us take an example of a cubic volume of air. Cubic volume of air. So if the molecules are far, it's called low density, and C cubic if the molecules are closely packed, then we can say that it has high density. So if the air is flowing around the airfoil and its density changes, it's called compressible flow. So here in the beginning of the airfoil, if we have dense air, and as the flow goes on around the airfoil, we see that the density is decreased. Then this change in density, then this flow will be called as compressible flow. This condition applies during high speed, but at low speed, if the density at the tip of the airfoil is low, and as the flow goes around the airfoil is the same, then when the density does not change, it's called incompressible flow. Now let us take another example of a water balloon. If a balloon is filled with water and no matter how much you squeeze it or crush it, the volume of the water does not change, and it always comes back to its original position, which means the volume of the water remains the same. Now remember that density is equals to mass by volume. So when we consider the water balloon example, our mass is constant and our volume is also constant. So in turn, our density is also constant, which that says that water is an incompressible fluid because density is constant. Consider another example where we fill a balloon with air and we keep it in the fridge. The temperature will go down and the balloon will decrease in its size. So in case of the air-filled balloon kept in the refrigerator, we can say that the volume of the balloon has gone down and must stay the same as the air is not come out of the balloon. Third, the numerator is big and the denominator is small, which gives this whole number will become big. For example, we have numerator as 100 divided by denominator as 0.1. We get through density as 1000, which is a lot. So we can say that density is changed, the mass is same, and the volume is changed, which eventually leads us to a compressible flow. And now through this, we can say that water is incompressible and air is compressible in nature. I hope you would have understood the difference between compressible flow and incompressible flow at today's session. Let us move on to Bernoulli's equation, energy equation, and Euler's equation in our next session. Thank you.